Hello, have we got your attention? Good, let's talk about climate change. Increasing atmospheric concentrations of greenhouse gases limits heat escaping Earth towards space. This causes global temperatures to rise in a human enhancement of the natural greenhouse effect. The largest culprit, CO2, accounts for 81% of the UK's total greenhouse gas emissions. Would you believe that in 2017 alone, the transport sector emitted 124.6 megatons of CO2 in the UK, the mass of 8.5 million double-decker buses? But we are not without solutions. A fresh mentality is emerging. Instead of viewing CO2 as our enemy, we must consider it our friend. Carbon dioxide utilisation, also known as CDU, is an innovative method of using CO2 to make desirable products. So, how does CDU work? Following the emission of flue gases from power stations, the first step of CDU involves the capture, separation and purification of such gases. This removes undesirable waste, leaving pure CO2. Methods for capture include absorption processes. Unfortunately, CO2 capture increases the energy usage within power stations by 25 to 40%. Therefore, step 2, the utilisation of CO2 to generate desirable chemical feedstocks, is essential to offset costs and ensure CDU is a net consumer of CO2. Finally, chemical feedstocks are used in the production of a diverse array of products. Meanwhile, at the University of York, we are lucky to have the Green Chemistry Centre of Excellence, a world-leading facility for green and sustainable chemical research. The GCCE is particularly interested in CDU to not only reduce CO2 emissions, but to also produce useful feedstocks such as cyclic carbonates. Research has focused on producing cyclic carbonates via the reaction between CO2 and epoxides, as the demand for them is expected to grow rapidly due to their role in lithium-ion batteries for electric vehicles. To reduce the current commercial dependence on fossil fuels, it is essential that we produce more active catalysts for the reaction to ensure that it is a net consumer of CO2. A research paper led by James Comerford found that seaweed powder, which contains active metal halides and amino acids, is an effective catalyst. However, this process is limited by its use of high temperatures and the production of diol and chlorinated side products. Limitations of the real-life practice of CDU include the lack of global infrastructure, the time that CO2 is sequestered for, and the requirements for green technology to make the process carbon neutral. So, how could CDU be executed in the most environmental and economically sustainable way? It is only by manufacturing both low-value, large-scale fuels with high-value, small-scale chemicals in a combined approach to the circular economy that CDU will appear attractive. We believe that instead of comparing CDU, we should use it cooperatively with other green processes in a more holistic approach to green chemistry. It is only by continuing to invest that we guarantee a bright future for generations to come.